Every action movie, every video game, every military recruitment ad shows you the same image, the M4 Carbine, flawless, unstoppable, and perfectly reliable. But what Hollywood will never show you is the hidden truth hiding inside this weapon's procedure. Every single time this carbine fires, it deliberately blasts superheated carbon gas directly into its own internal mechanism. It is a design choice so controversial that engineers have debated it for over 60 years. The M4A1 Carbine, the backbone of the United States military and over 80 allied nations, runs dirty by design. To understand why the world's most trusted combat rifle intentionally poisons itself with every shot, we must tear apart its mechanical anatomy, piece by piece. The story of the M4A1 begins with a catastrophe. In 1956, a brilliant aerospace engineer named Eugene Stoner designed the AR-15 at Armalite. His radical concept used lightweight aluminum and advanced polymers to create a rifle that weighed nearly 2 pounds less than anything in military service. The United States military adopted Stoner's design as the M16 and rushed it into the jungles of Vietnam. The result was a disaster. Soldiers reported constant jamming, failures to extract spent casings, and chambers corroded by the humid tropical climate. Men died with jammed rifles in their hands. The cause was a combination of the wrong gunpowder, a missing chrome chamber lining, and a military command that told soldiers the rifle was self-cleaning. After emergency modifications produced the M16A1, the platform slowly regained trust. Decades later, a shorter, lighter variant was born, the M4 Carbine in 1994, and finally the M4A1, upgraded to full automatic fire in 2014. The heart of the M4A1 controversy is its direct impingement gas system. When a cartridge is fired, the bullet accelerates down the barrel. As it passes a small hole called the gas port, located approximately 7.5 inches from the muzzle, high-pressure propellant gas is diverted upward into a thin stainless steel gas tube. This superheated gas, carrying temperatures exceeding 1400 degrees Fahrenheit, travels backward through the gas tube and enters the gas key, a small component bolted to the top of the bolt carrier. Once inside the bolt carrier, the gas expands within the space between the bolt and the carrier, forcing the carrier rearward while the bolt remains momentarily locked. This is the fundamental principle of direct impingement. The gas itself acts directly on the bolt carrier, with no intermediate piston. Unlike the AK-47, which uses a long-stroke gas piston that keeps combustion gases entirely separate from the bolt, the M4A1 dumps every molecule of hot, carbon-laden gas directly into its own action. The locking mechanism of the M4A1 is a masterpiece of precision engineering. The bolt head features 7 radial locking lugs arranged in a star pattern. These lugs correspond to 7 matching recesses machined into the barrel extension, commonly called the star chamber. When the bolt is pushed forward by the return spring, the cam pin riding in a spiral track on the bolt carrier forces the bolt to rotate approximately 22.5 degrees clockwise. This rotation locks all 7 lugs firmly behind the barrel extension, creating an airtight seal capable of containing over 55,000 pounds per square inch of chamber pressure. On the face of the bolt, a spring-loaded extractor claw grips the rim of the cartridge case, while a small plunger-type ejector sits recessed in the bolt face, compressed under spring tension. Together, these components form the critical interface between the rifle and the ammunition it feeds. The full automatic firing cycle of the M4A1 is a symphony of controlled violence, completed in less than 1/10 of a second. When the shooter pulls the trigger, the hammer is released and strikes the rear of the firing pin. The firing pin drives forward into the primer, igniting the propellant charge and generating 55,000 pounds per square inch of gas pressure. As the bullet exits the gas port, diverted gas rushes back through the gas tube and into the bolt carrier, forcing it rearward. The cam pin forces the bolt to rotate counterclockwise, unlocking the 7 lugs from the barrel extension. The bolt carrier continues rearward, extracting the spent case from the chamber and striking it against the plunger ejector, which kicks it out the ejection port. The bolt carrier then compresses the buffer spring in the receiver extension. This spring drives the carrier forward, stripping a fresh round from the magazine, chambering it, and rotating the bolt into lockup. In full auto mode, the auto sear holds the hammer until the bolt is fully locked, then releases it automatically, repeating the cycle at 700 to 950 rounds per minute. This is what separates the M4A1 from the older M4, which used a 3-round burst mechanism. This is where the M4A1's most controversial trade-off reveals itself. Because the direct impingement system routes hot combustion gas directly into the bolt carrier group, every single shot deposits a layer of carbon fouling, powder residue, and metallic particles onto the internal components. After several hundred rounds, the bolt carrier group, gas rings, and interior of the upper receiver become coated in a thick, abrasive carbon sludge. This buildup increases friction, degrades the gas seal around the bolt rings, and eventually leads to malfunctions. The three most common failures are: failure to extract, where the fouled extractor cannot grip the spent case; failure to feed, where carbon buildup prevents the bolt from fully chambering a new round; and bolt override, where a live round rides over the top of the bolt instead of being fed into the chamber. In comparison, the AK-47's long-stroke piston vents combustion gas through ports in the gas block, keeping the bolt carrier group relatively clean even after thousands of rounds without maintenance. The M4A1 uses a 14.5-inch barrel, significantly shorter than the original M16's 20-inch barrel. This reduction was a deliberate trade-off between ballistic performance and combat maneuverability. The 5.56 by 45 mm NATO cartridge generates approximately 26,000 foot-pounds of muzzle energy from the M16's longer barrel, achieving a muzzle velocity of roughly 3,100 feet per second. But in the M4A1's shorter barrel, the propellant gases have less time to accelerate the bullet, reducing muzzle velocity to approximately 2,900 feet per second. This velocity loss reduces effective range from roughly 600 meters to approximately 500 meters and decreases terminal fragmentation at longer distances. However, the shorter barrel dramatically improves handling in vehicles, urban environments, and close-quarters combat. The barrel itself features a 1-in-7-inch twist rate, chrome-lined bore and chamber, and is optimized for the 62-grain M855 ball round, spinning the bullet at over 300,000 revolutions per minute for gyroscopic stability. Now let us follow the bullet on its entire journey from chamber to target, and see exactly where the M4A1 falls behind its longer-barreled ancestor. When the primer detonates, the propellant erupts at over 5,000 degrees Fahrenheit, generating a wall of gas pressure that accelerates the 62-grain M855 bullet down the barrel. As it travels through the chrome-lined bore, the 1-in-7-inch rifling grooves bite into the copper jacket, spinning the bullet to over 300,000 revolutions per minute. The moment the bullet exits the muzzle, a supersonic shock cone forms around it, creating the distinctive crack heard downrange. But here is where the barrel length difference becomes critical. From the M4A1's 14.5-inch barrel, the M855 leaves at approximately 2,900 feet per second. From the M16's 20-inch barrel, that same bullet exits at 3,100 feet per second. That 200 foot per second gap may seem small, but it compounds dramatically over distance. At 100 meters, the difference in bullet drop is barely half an inch. At 300 meters, the M4A1's bullet has dropped 15.2 inches compared to the M16's 11.8 inches. But the real consequence is terminal performance. The 5.56mm M855 round is designed to fragment upon impact, but only when it strikes above approximately 2,700 feet per second. The M16 maintains this fragmentation velocity out to roughly 200 meters. The M4A1 drops below this critical threshold at around 150 meters. Beyond that range, the M4A1's bullet tends to pass through soft tissue without fragmenting, dramatically reducing its stopping power. Wind drift tells a similar story. In a 10-mile-per-hour crosswind at 300 meters, the M4A1's bullet drifts 8.2 inches compared to the M16's 6.5 inches. The energy retention chart confirms it. At 500 meters, the M4A1 retains only 65% of the energy the M16 delivers at the same distance. This is the engineering reality behind the shorter barrel. The M4A1 trades long-range lethality for the close-quarters dominance that modern warfare demands. What truly separates the M4A1 from every other military rifle in history is not its caliber or its gas system. It is its unprecedented modularity. The introduction of the Picatinny rail system in 1995, formerly designated MILSTD 1913, transformed the M4A1 from a simple carbine into a modular weapons platform. For standardized accessory rails machined into the handguard allow operators to mount virtually any combination of optics, weapon lights, infrared laser designators, vertical grips, and bipods. Modern variants have transitioned to the MLOK attachment system, which is lighter, slimmer, and more ergonomic than the original Picatinny design. With a suppressor threaded onto the muzzle, the same base rifle can be configured for close-quarters battle, designated marksman roles, or breaching operations. This modularity philosophy, the concept of a single weapon system adaptable to any mission, is the reason the M4A1 has been adopted by special operations forces, conventional infantry, and law enforcement agencies across more than 80 nations worldwide. The M4A1's reputation for unreliability is largely a relic of its past. In the controversial 2007 extreme dust test, the original M4 recorded 882 stoppages over 60,000 rounds, a failure rate of approximately 1.5%. This placed it behind the HK416 piston-driven competitor. But the modern M4A1 is a fundamentally different weapon. The military implemented a series of critical improvements: a heavier H2 buffer that slows the cyclic rate and reduces bolt bounce, an improved extractor spring with a rubber O-ring insert for more consistent case extraction, a fully chrome-lined chamber and bore for corrosion resistance, and ambidextrous fire controls. These upgrades have reduced the stoppage rate by over 50%. The modern M4A1, when properly lubricated and maintained, achieves a mean rounds between failure exceeding 6,000 rounds. More importantly, operators who clean and lubricate their bolt carrier groups regularly report tens of thousands of rounds without a single malfunction. The M4A1's weakness was never the design. It was always neglected maintenance. The M4A1 Carbine is a study in engineering compromise. Eugene Stoner's direct impingement system made it lighter, simpler, and more accurate than any piston-driven rival. But it paid the price in cleanliness, requiring disciplined maintenance to function at its peak. Its 7-lug rotating bolt locks with surgical precision. Its modular rail system redefined what a military rifle could become. And its troubled history, from the rice paddies of Vietnam to the deserts of the Middle East, forged a weapon that adapted, evolved, and ultimately earned its place as the most widely deployed carbine in modern military history. The M4A1 does not run clean. It was never designed to. But in the hands of a trained operator who understands its anatomy, it runs when it matters most. What weapon should we dissect next? Let us know in the comments below, subscribe to Arsenal Anatomy, and we will see you in the next breakdown.